My name is Spencer Gibb. I've been on the Spring team for almost 11 years, which is crazy every time I say how long I've been on the Spring team. I started the Spring Cloud project with Dave Sire in 2014 and been on the Spring team ever since. Today's talk is not specifically about Spring Cloud, but in general, what Spring can do to help us build APIs, what tools they have, how to test them, how to consume them. So I kind of give a high-level overview of a lot of things that are in Spring. So this is kind of what will be high-level things that we'll be talking about. I give on most of the slides, there are a couple of URLs, typically the reference documentation to the feature I'm talking about, and then typically how to enable that or use that in Spring Boot. You don't have to take pictures. I will publish these slides sometime today, and there will be a link at the end. So if you want, you'll be able to get the slides that way later today. How many people here are familiar with Spring a little bit already? Oh, okay. Most of you. Welcome. So hopefully I can teach you something helpful or useful. I don't mind taking questions as we go, so if you have them, please let me know. Does anyone know how old Spring is?
Right, 15 years?
I heard 15, 20? Yeah, it's 20 or 21, depending on if you go on first commit or first release. So it's been around for a while. So we're going to start talking about HTTP APIs. And the venerable Spring MVC, right? Again, users who have used this, probably the same group of people that raised their hands for Spring. This was the original model view framework since, I think it was 3.5 or 3.0. It's been typically based on annotations, and it allows you to map easily to the different HTTP methods. But if you want to do something specific to a servlet, any servlet filters or what have you can be registered as beans. And we have support for all the typical servlet containers. If you want to use a standard annotations, you can use JAX-RS as a Spring MVC alternative. So this is pretty familiar to folks, right? Simple REST interface at /users, and then each one of these handles a different operation based on those users. So fairly standard. This is the most straightforward thing we can do in Spring to deliver an API to our customers. Then a number of years ago, we created something called Spring Web Flux. This is an asynchronous, non-blocking framework. It's unique in that it allows you to basically do more with the same hardware, right? We use Project Reactor, which uses Netty underneath, so it's an event loop type framework. If you're familiar with Node.js, okay, so it's a similar architectural style to that. And in WebFlux, so these two terms are from Project Reactor. Mono is 0 or 1 things, and a flux is 0 to many. And interestingly, if you don't have anything servlet specific in your controller methods, then your controller could be a WebFlux controller because it reuses a lot of those same annotations. And again, the same servlet controllers can be used to run Webflux as well, but the default is Netty. So here's that same API, but now you can see we're returning a mono here, right? So as a rule, you shouldn't do any I/O that is blocking in a Webflux application, because that subscriber, the subscribe, when the container says, okay, do work, is as late as possible, and then it gets scheduled on that event loop. So for certain classes of applications, this can be very, very useful. Also to note, though, recently you have virtual threads. So there's another class of applications where the servlet stack plus virtual threads might get you along as far as you need to go without having to go into Webflux. Because let's face it, Project Reactor, for those that are familiar with it and have tried to use it in anger or not, can be difficult to use. So those were the annotation-based models, but for those that's not their preference, they prefer something more functional. Each one of these projects is available in a functional DSL. So simple functions are used to route and to handle requests. There is a static kind of builder method on a class called router functions that I'll show here in a second that allows you to create functional controllers. And again, same servlet containers, but here you can see it's very, very different from what we were looking at previously, but essentially this is the same API that I showed previously in the annotation method. Oh. So you can see the different HTTP methods, and then in this case, we're passing a method reference that actually handles those requests. There's also functional version of Webflux. That router functions is just in a different package, but otherwise very, very similar to the webmvc.fn. This also lends itself to other programming languages that you might use on the JVM, like Kotlin, that are focused a little more on the functional style as well. In fact, I think there's a specific Kotlin DSL for these that is more idiomatic to Kotlin. You can handle all sorts of content in these, right? You have your typical JSON, right? That's kind of the default that everyone uses. But we have all sorts of types that can be handled in Spring Framework, whether it's plain text, CBOR is a binary encoding. It also can support streaming HTTP requests, right? So, for example, server-sent events, you can supply from Spring Framework. And then you can also populate views, whether that's Timeleaf. I've created PDFs out of Spring controllers, right, for folks to download. Or Mustache, if you're familiar with Mustache. That's pretty popular now, too. All right. Another project that might be able to help you provide APIs is a project from Spring Data. So Spring Data, for those that, sorry, we're getting a little feedback. That seemed like I moved in it. Anyway, so Spring Data provides, is that better? That's funny.
Yeah, there's an echo delay.
Okay. So Spring Data provides access to various database technologies, whether that's SQL, NoSQL, it runs the gamut. And its job is to provide easy access to that data for you. But there's a sub-project called Spring Data REST. And what it does is given, so the abstraction in Spring Data that you use is called a repository. So given one of these repositories, it will auto-generate a REST API for you based on that repository. So including all the custom queries and accessors and updates and things like that. So it's very, very slick, and for, again, certain classes of applications, sometimes this is the simplest thing and quickest thing you can do to get up and running. We also have support for a lot of the IaaS databases. So think Azure, AWS, GCP, those kinds of things that have their custom databases. There's typically a Spring Data module for those. So these are typically hypermedia-driven RESTful resources, if you've heard of that. And this project that has originated from Spring Data, Spring Harios, I'm not even sure how to say it correctly, is hypermedia is the engine of state, right? So this gives you links in your responses that allow you to navigate the data that has come back. So Spring Data REST might give you something that looks like this, right? And you can see those links. So this is just a list of all employees, but for each employee, it gives you a list or a link directly to the individual employee. So super useful to get up and running fairly quickly. So here's one of my projects, Spring Cloud Gateway. Is anyone familiar with this one? We've got a couple. So far, we've talked about kind of individual projects, but most of us don't work in that much isolation, right? We work for some larger project or company, and there might be multiple services that folks need to access. So Spring Cloud Gateway can be used as a central point to aggregate your APIs for consumers. That way, they don't have to know about all the individual services. They have a one-stop shop for services. It's also nice because it's a single place where you can address cross-cutting concerns like security, resilience, fault tolerance, things like that.
If I may ask,
Sure.
is that to be equated with Kubernetes ingress control? Is that the same space?
So the question he asked is if it's a similar space to the Kubernetes ingress controller. They do some similar things. We have a lot of customers that actually run this behind Kubernetes ingress. So because it can do a lot more advanced things, and it can also do custom things where you can't, some of those more advanced and custom things can't happen in ingress. If that makes sense. So a lot of it is typical routing, and even those. No, it's not. Yeah.
And if I may also go back to the previous slide on the REST data. This one is the on-the-wire payload. Will you ever need to see this at all?
See it how? I'm not sure what you mean.
Is this, so the REST data you don't write any REST controller?
No, you don't. You just get a certain URL, right? These URLs here at the bottom.
And all you have is a repository?
Yes.
And once you have the repository, how was this mapped to that? Did you do some?
I think you can do it by hand, and it can also find all the repository beans in the Spring context and expose them just kind of automatically.
Okay. So this is the on-the-wire. This is a payload.
Yes, this is a payload. Yes, this is not configuration. This is what an API client would consume.
Consume.
Yeah.
Okay. Thanks.
So there are Webflux and MVC versions of the gateway. And when I built it, I wanted to focus on developer experience. One of the things that we wanted is for developers to be able to do this, right? It's not a ticket, it's a release, right? If it's a project that you're in control of and you need to fix something, you can run it through CI and get it pushed out that way. It has integration with other Spring Cloud projects. If you're not familiar, there are things like service discovery. So your gateway, you probably have more than one instance, right? And you have more than one instance of your services. So it's able to, if you register them all correctly, or if you use something like Kubernetes, it can route appropriately to all those instances with client-side load balancing. Things like circuit breaker and retry and other things. We do have a commercial managed version on Cloud Foundry and Kubernetes that provides some additional functionality over the open source version. So any more questions in the HTTP space before we move on? All right. So GraphQL has recently been popular. So GraphQL is two things. It is both a runtime to execute query language and the server-side runtime, right? So it supplies both things. It's not tied to any specific data store or storage engine or anything like that, but just backed by your existing code. So you define, one of the nice things about GraphQL over simple REST is that you get to define concrete types, right? So there's some type safety involved here. And you can say, this attribute is nullable, these aren't. You can also have complex types like the product there, or dates or things like that. So it gets a little more structured, and then it allows you to query for those things individually, right? With a REST API, you say, get me the user, and you get all the information about the user. If you want a different view of the data, you need to create a different API for that data, right? With GraphQL, when you make the query, you can ask for specific points of data from the objects that you're requesting.
Well,
Go ahead.
Why is GraphQL not over HTTP?
It typically is, but it doesn't have to be. But it typically is over HTTP.
Yeah, all the time says so.
Yeah. It's not tied specifically to it, but most people effectively do it over HTTP. You get to define queries up front. So it's very useful because it allows your various teams to collaborate and define well-defined queries that you're able to run. You also get mutations, so not just queries. In the Java space, GraphQL Java has been around for a while. GraphQL in general, typically thought of from Facebook in the teens. GraphQL Java is the most popular project to access GraphQL in the Java space. And then a number of years ago, Netflix started a project called DGS. And at about the same time, Spring started a project for GraphQL. So we were collaborating with the folks from GraphQL Java, and DGS and Spring for GraphQL were kind of being created in parallel. And as Spring for GraphQL matured, slowly everything that it did, DGS replaced with Spring for GraphQL. And so now they only provide a layer on top of Spring for GraphQL. Sure.
So the Spring GraphQL GraphQL.
You're gonna have to speak up. I can't hear you.
So what is the parent of the Spring GraphQL? GraphQL Java is the parent.
The library that we use underneath is GraphQL Java. Yes.
Could you repeat the question?
Yeah, he's asking what Spring for GraphQL was built on, and it's GraphQL for Java. Yeah, we collaborated with the team that maintains and runs GraphQL for Java. So
how are you injecting the theme?
So it's a separate project, and you can consume straight. It has a few different features from Spring for GraphQL, and so depending on if you need one or the other, I mostly put it up as the collaboration between the Netflix team and the Spring team. But you do get a similar controller-like programming model, right? Which is nice. So if you're familiar with WebMVC, it's the same. You literally at controller, but instead of get mapping, post mapping, for example, you have query mapping or mutation mapping. And again, most people do it over HTTP, but it could be WebSockets, it could be RSockets, so it could be any of those things.
Is that the same package controller, or is it?
Yes. Yeah, controller is in a central package, and then it can be used as sub. Yeah. So REST controller is in web, right, which has at controller as a super annotation on it. So as we get into other styles of APIs, we have something new that is being worked on. Who's familiar with gRPC? A few of you? Okay, so gRPC is a binary protocol. The G, does anyone tell me what the G stands for? Yes, right, so it's originated in Google as a high-speed alternative to HTTP, right? It's typically text, and so you have the overhead of encoding. So gRPC was an attempt to make things a little more performant. So it uses something called protocol buffers to define the data that you're sending. And these are .proto files. I'll show an example of one here in a second. You define a protocol buffer, and then there is a compiler that you configure, and then you can create clients for multiple languages, right? So this is a polyglot framework, and we've starting to add support for it in Spring. So this project, the one at the top, is creating the support. It'll also have Spring Boot auto configuration, actuator integration. I was just talking to a couple of the folks on the Spring security team there. It's on their radar. They want to integrate with Spring Security for securing these endpoints. And there are starters for both Netty, so in the Webflex side, and for servlet-based applications. And an interesting thing currently, so one of the oddities of using gRPC, there are a couple of community attempts to do this, is that you create a Spring Boot application, and then you start a gRP server listening on a different port, right? So you're listening on multiple ports. But with the servlet integration currently as it stands, it will accept gRPC or regular HTTP requests all listening on the same port, which is very nice. gRPC is over HTTP 2, so it can It can do that, it just takes some work, and hopefully they'll be able to get that on the WebFlux side as well, so you don't have multiple open ports.
At the,
Sure.
at the previous slide, the code generation. Is this from, you define a protobuf schema, and then you compile it to get the marshaller and non-marshaller? Is that what?
Yeah, so he's asking about the code generation, and so, yes. So what you define here, so yeah, so this is a proto file, and you have the service, which are the operations, and that's used to generate the server end that does, and it can also create clients, and so those do the serialization automatically for you.
Okay. And then this generated code, how will you use it? Will you plug it in a?
Give me a slide. So he's asking how to use it. So yes. So in this case, let me see if this works. Oh, go away. This guy here is the generated code that you extend. You create a service, and then that's all you have to do. You just extend that generated code. And then you can write the functionality of what you need to do on that particular message. So this is the say hello, right? So this is the implementation of this RPC call in this slide, okay? And in this case, we're just using a command line tool to do that, but you don't have to. It also generates client stubs that are created as beans as well. So this is a sample test. So this client here is generated, and we're just injecting it and using it in our test. So we're able to send requests using the generated client as well.
So that generated client will have the HTTP2 embedded, somewhere below in the stack.
Well, so that's some of the work that we've done is so that it reuses the stack on the server side that Spring Boot already auto-configures. So this is exciting. I don't have an official timeline or anything for this, but I'm hopeful that this will move out of experimental later this year. So it'll become part of Framework, part of Spring Boot, and able to be used by everybody. So now another way to access messaging is through a couple of Spring Cloud projects called Stream and Function. So Spring Cloud Function embraces Java util functional interfaces as the programming model, right? So this is not a Spring specific API. Spring Cloud Stream are binders to different messaging technologies. So you can create beans of type supplier, function, or consumer, right? And then these are either send messages or receive messages from some kind of message broker. So as well as various open source brokers, there is IaaS integration. But you can use this to build message-driven applications, right? So in a lot of cases, if you have a bunch of microservices, probably the worst thing that you could do is have a big, huge tree of blocking HTTP calls, right? A lot of times it's might be more appropriate to have an asynchronous message be sent for your system to handle handle later. So we have support for things like Kafka and Rabbit. Pulsar, and there are also community projects for other various message brokers that exist out there. One of the things that the maintainer of Function and Stream, his name's Oleg, we've been working on, is integration into Spring Cloud Gateway. So imagine we've had this on our radar for a long time, and we're finally able to get to it. So you have an API gateway, might be routing to microservices. You can now also route directly to message brokers over HTTP, right? So this, for whatever system you might need that would go directly into a message broker, we can set up things in Spring Cloud Gateway to do that. So we're super excited about that, and it went into a milestone in February, so it's available out there to try.
I know I'm asking.
No, you're good.
The I and O seems to be implying it is to be used like a stream and a map.
So this is a Java util function, right? So one of the parameters input, one is out.
But when you use it on a message, you will use it as a terminal operation. You will only have out.
So a supplier only has out, consumer only has in, and function has in and out.
Oh, that's right.
Yeah. And function can be individual messages, or it could be streams of messages, depending on how you configure it and what you're using. So it's a really nice abstraction. So we also have support for the venerable Java message service in Framework, if you still use that. So it's very similar to the JDBC template type integration with JMS template. So boot provides auto configuration for things like ActiveMQ, Classic, and Artemis. Another related technology in the messaging framework, I've mentioned it once or twice, is WebSockets, right? So this is, WebSockets are a little bit nebulous, right? It's you talking over HTTP, but once you do, there is no real standard of what you do in that stream, right? So Framework can help you do that. So that's just kind of a definition of a WebSocket. So typically these are something you use from a browser to a backend, right? It doesn't make a lot of sense to do it from something that's not already speaking HTTP. One of the reasons it's interesting, though, is I'm sure there are at least one or two of you who have worked somewhere where you literally only have two, it might even be one port now, right? Like you literally have 443 and that's it, right? You don't have any other port to work with. And so WebSockets gives you that flexibility to run some more efficient communication over our firewalls. So if you want to use WebSockets in Spring MVC, there is the starter that you might use. The WebFlux support is included if you're starting a WebFlux application. All right, and last in the messaging section, has anyone heard of RSocket before? So RSocket is, I'll just read it. It's easier for me to read it than it is to try and paraphrase it. An application protocol for multiplexed duplex communication over a particular protocol, whether that's TCP or WebSockets, HTTP2, UDP, whatever it is. There are 4 interactions that you can define in RSocket. Request response. So this looks closer to what we're used to in HTTP, right? So that's the first one. RS is request stream. So this would be analogous to something like server sent events. You make a single request and you get a stream of objects or responses back. A channel is a bidirectional stream. And this is all binary, right? So super efficient. RSocket was created by former Netflix folks that wanted to be able to solve some of the typical distributed system problems. There are various layers you can solve these problems in, right? A lot of what Spring Cloud was solving those in libraries, right? The other extreme is you solve it in the platform, right? All of your hardware will take care of it. And then there's just not a lot of flexibility in that one. So this one was an attempt to solve some of those issues at the protocol layer, which is unique. And the last mode is fire and forget. So this would be like, I'm just sending a message, I don't need a response. And the interesting thing when you use RSocket, and it's polyglot, there are clients and implementations in multiple languages, including Java, JavaScript. So you could have an RSocket client in a browser, for example, that communicates over WebSocket to a server running in Spring Framework. But once that connection is created, there is no server client concept anymore because either side can initiate requests. So it's a really neat interaction model. So there's a thing called reactive streams that allows something called back pressure across the network. So HTTP, you might get a server busy 500 error, right? But RSocket can communicate that kind of information across the wire. And so it can inform the clients, hey, you need to slow down and take less from us, for example.
RSocket, there is no RFC. This is a Spring specific.
So RSocket is a community-run project. There is no RFC, no, but it's not specific to Spring.
That's why you have JavaScript.
Yeah, like I said, you could do it in JavaScript or Go, or Facebook uses this for their communication from their mobile app to their data center, for example.
And so is the transport layer WebSocket or HTTP2?
It's pluggable. Yeah. So it could be UDP. They're working on HTTP3, so the transport layer is pluggable. And if there's a feature in RSocket that is implemented in the transport, they will delegate it. Otherwise, they will implement it on their own. That's where you can read more about RSocket. So far, everything we've talked about has been specifically about us as developers creating APIs for someone else to consume. So these next sections cover different aspects of the holistic approach of creating APIs, right? So including testing, right? So how do you test these things? And Spring provides a number of ways to do that. One of them is mock MVC. So this is a very specific testing framework for Spring MVC applications. And it's something that you can do so you don't have to create a full integration test so this is more on the level of unit testing a controller, right? So it doesn't start up a container and listen on a port and network calls aren't made. And we have a class called Web Test Client that allows you to integrate this, and I'll show you here in a minute. But you could also then go on to running an integration test over a server. So given a controller, you can do some things like this where you make requests at specific endpoints and expect statuses, and there are assertions that you can make while you're doing the testing. So another thing that we have integration for is WireMock. So this is a little more on the integration testing side. So WireMock allows you to programmatically define external APIs that you can then make actual HTTP calls to. You can do that configuration in Java. You can also do JSON configuration. You can set up all sorts of rules for matching. For this path, I need this kind of response for this test, right? There's also facilities to record HTTP traffic and play it back. But it has more support than just something like MockMVC, so it also has support for gRPC and GraphQL. And this is provided by a package in Spring Cloud. Well, WireMock is a standalone project, but the Spring configuration of it comes from Spring Cloud Contract, which we'll talk about a little more here in a bit. But to show you what this looks like, there's auto configuration, that top annotation there. And then we define what we want the server, how we want the server to respond, right? With that stub 4 here in context loads. So you define the full HTTP response there. And then you call the service and it will verify that WireMock responded properly. And then next we have Spring Cloud Contract. So, sure.
So here you're actually running Tomcat, random forest. And the previous case, the regular test also, you're running an embedded.
Actually, Tomcat doesn't have to be running in this case because WireMock actually opens a port and listens. That's just an artifact of me copying and pasting. I apologize. This test doesn't have to have a Spring Boot web server running for this to work.
And this will test the complete stack. Your service, your current repository, you need to have an active database.
So this is for mocking an external service, right? But that you depend on, for example, not your full stack. Does that make sense?
So you depend, your Spring Boot, Spring depends on an external.
Yes. And so you're able to mock those endpoints.
Web client is what is being mocked.
The server that the web client is talking to is the thing being mocked. That makes sense. So Spring Cloud Contract is, the idea here is to move, if you're familiar with TDD, test-driven development, kind of to the level of software architecture, or at least APIs at the least. So Spring Cloud Contract allows you, consumers and producers, to collaborate on APIs and then have facilities so that you can know when the other side has created a breaking change automatically. So what happens is you create stubs for a service, and they get published to a Maven repository, your local Nexus, for example, and then a consumer will consume those and run tests against them. And if the producer side has made a breaking change, then you can see that in CI. And that's kind of the general idea. There's a lot more involved in Spring Cloud Contract, but the idea is that there's collaboration between producer and consumer. Think inside of a large organization where you have teams providing APIs and then other teams inside of that organization consuming them.
Is that contract, what's the nature of that contract? Is that like an open API or is it?
So he's asking what the nature of the contract is, and it can be open API. There's someone wrote integration for open API. Otherwise, it is just simple REST APIs or messaging APIs.
But it's not like a library, in-process library that jar file you.
It is the stubs that get generated are a jar file that you consume during testing. Yes. So basically, the producer pushes these stubs to a repository that the consumer can pull down in there and run as part of their testing. So the idea is that that doesn't show their shapes on that. That's hilarious. I need to do different colors or outlines. The API producer pushes a stub of a service that they provide to an artifact repository, and the consumers consume it. They run their tests, and if there's a breaking change, their tests will fail automatically, right? And then they can go back to the team and say, hey, you broke us, right? So it's a nice way to do consumer-driven testing.
Is that measured? Is that stable?
Yes, it's been around. He's asking if it's stable. It's been around for a number of years. There are also other implementations of this besides Spring Cloud Contract that you can find that aren't specific to Java or Spring. One of my favorite testing features that I've been using recently are test containers. Raise a show of hands have heard of test containers? A few of you. You've certainly heard of containers in general, right? Docker containers or the like. And so test containers is pretty unique, and it provides a library to use these images during your testing phases in your Java application. So Spring Boot recently, in the last, how long has it been? A couple of years that they've added this? I'm looking at my teammates over there. And what you can do is, instead of having to have a database, using an in-memory database in your testing as opposed to integrate, whatever you're really running in production, you can now test locally against the same database that you would use, or messaging service, or whatever the case may be, in your local environment. And it is automatically run and managed by Spring Boot. So databases, message brokers, basically almost anything that there's a Docker container for, you could spin up in testing. The other thing that Spring Boot provides is a way to, now this typically for a Spring Boot test, right? You would have test containers and you would run your tests that way. But when you're building an application, you're not just typically running tests. You want to run your actual app and have it with backing services. So there's facilities for, I guess it's called a test main, for example, that it will run your application not as tests, but it will use those images that you've defined in your tests to start all those backing services and automatically bind them to your Spring Boot application, the properties, right? Whatever the port it happens to be running on, the credentials you need to connect will automatically be configured in your Spring Boot application. So it's really, really slick.
So, trying to dodge it, you'd like to do some kind of automated integration testing, and then you spin up the Docker image, the container.
Yeah. So
map the port to a local port, and that you plug in. It will plug into your configured application. Yeah.
Yeah. So the kind of the life cycle previously. You'd have, for example, you could use something like Docker Compose, right? You define a bunch of images with a port, but then you'd have to configure your application to point at all those correct things. And so the idea is that Spring Boot's integration will automatically start the images and configure all those properties for you automatically. So it's really, really slick.
And all of that it's doing because your test has the annotation test container.
Yeah. Yep. So if you go to that URL, it will give you examples of what that be. And again, I'll give a link to these slides at the end that will be available later today. So now we have the other side of APIs, which is consuming them. We're running short, so I'll kind of go through these a little bit. REST template is the old style of venerable. It's been around forever. It's pretty rock solid. But if you ever looked at the Javadoc page for REST template, it is massive because there are like 4 or 5 overloaded methods for everything, and it can be overwhelming to look at and not really easy to use. But it's there. It's been there forever. Then when we created Webflux, we created Web Client. The really nice thing about Web Client was that it has this nice, fluent API to make HTTP requests. The trouble is that this required Webflux. So if you wanted to use Web Client, even if you weren't running a Webflux application, you had to bring Webflux into your project.
So for the web clients, we do have the integration using the Webflux.
Sorry.
So we do have the integration for the web clients without using the Webflux, but we don't get advantage.
I'll get to that in a second. So hold on a second. So here you can see the nice fluent style here at the bottom, which allows, it's just so much nicer to be able to have your IDE, autocomplete the appropriate things for you. But you had to bring in Webflux, which not everyone was. So some people weren't moving over because they did not want to bring Webflux into their applications. And so in Spring Framework 6.1, we created REST client. So this is the blocking synchronous version of Web Client. So it's a similar fluent style API, and Webflux is not required. So if you don't want to use Webflux, use REST Client. You can configure the underlying client that actually does the HTTP request is configured the same way as REST template, and you can actually get a REST client from a REST template if you'd rather do that. So here's the same API call, but using REST client. The MVC gateway uses REST client to make all of its requests, because you can configure REST client automatically with Spring Boot properties, and so I wanted to be able to maintain that. So here's heard of Feign. Yeah, Feign clients, a few of you. So this was the idea to create a declarative HTTP client, right? So these are, this style is imperative, right? You are calling what you need to do as it happens. But this style is declarative, right? So rather than calling get, you describe what the client needs to do, and then something else execute it. Previously, it was Feign in Spring Cloud, but we moved that functionality into Spring Framework to provide it natively in Spring Framework 6.0, and my colleagues are working on doing the auto configuration to come later this year. So what this looks like in practice, there's a special annotation at HTTP Exchange, and so it looks like this. So at the top, you declare an interface and then annotate it, right? I want my post to happen on this path, right? And then Spring Framework decides how to make that happen, rather than you describing in code how to make that happen. This is a very nice way to package clients for other projects to use, right?
How are we going to configure the circuit breakers?
So he asked how we could configure, for example, a circuit breaker on this. That would be something that Spring Cloud does once Boot's auto configuration is done. Basically, there would be a hook. Hey, I want to add some kind of interceptor to these, and then you could configure a circuit breaker to circuit break this particular call.
And that will be a custom code?
No, it would just be, yeah, just some configuration to tell it to add a circuit breaker to this. Yep. Another question.
Would it be the same approach for implementing timeout?
He's asking if it would be the same approach for timeouts. In that case, you'd probably configure the REST client that is used underneath. We're actually working out those details. I've been in meetings the last few weeks working out those exact details, how you would configure, because you would probably want different timeouts for different services, right? They might have different things. So yeah, we're working on how you would do that in configuration, for example.
Because if I would be using interface client, I would be using only interface client, not REST client.
You could use both in your application. There's nothing keeping you from doing it. Yeah.
So, but what is the advantage I'm getting for using the interface?
What's that?
So, what is the advantage I'm getting using the interface client?
The advantage of using an interface client is that you don't deal specifically with the implementation of doing it. It's all very type safe, right? You could certainly create something that looks very much like this imperatively, right? But this is just a nice way to package things for other folks to use in a jar. That's typically what we see. People, for example, based on OpenAPI, will generate a bunch of interface clients. They don't have to generate the implementation of them because all they know is, similar information. I need to do a get, and this is what I send, this is what I receive, and then we let framework deal with the actual implementation, right? So if it's generated.
Is it fully mature?
The interface client stuff in framework is, what is coming is the auto configuration and configuration of those clients. So that's this part that's coming this year.
This is in Spring 6 point. What version is this in?
I think I had it on the previous slide. I didn't. 6.0. Yeah.
So you instantiated one of those with your beam, and somewhere you gave the details, host name, all of that.
Yes.
The server it will be getting it?
Yeah. So this part, what happened? Oh, wow, that was interesting. This part here, there's the base URL, right? That's comes from configuration. All of this stuff here will become part of the Spring Boot auto configuration.
And
You won't have to
so I assume that's thread safe and everything. That single
It's as thread safe as the REST client or web client underneath that is making the calls. So yes, they are.
So it will be a one-to-one?
Not necessarily. Well, there will be a way to group them. So sometimes you have multiple clients that point to a single URL, and we'll have a way to group those together as opposed to, so there could be a one-to-many. It kind of depends. There's lots of different ways we could configure things.
This is not for testing. This is your actual.
This is production code, yeah.
Replacement for web client.
Yes.
Where is the asynchronous? If it's asynchronous, like a flux on the other side.
Yeah, this can be, so this could be, you just define it to use a web client, and then you could put a flux.
So it'll be in the builder?
Yes, in one place it will be the builder, and the other place would be the, the return type where the parameter would have a flux or a mono on it.
Oh, I see. Okay. So
Yeah.
it's on the interface.
Yeah. Yep.
So it will optionally, looking at the interface, for example, one of your methods in the interface could be a synchronous one, and the next could be a asynchronous one, but with a flux of mono.
Yes.
And then it will, the actual steps, the actual series of things that will happen behind the scene will be very different.
So he's asking about asynchronous execution. Basically, you would configure a client to use web client, which is asynchronous by default, or REST client. So you either get non-blocking, all, or all blocking. So there's no way to have, so if you did have a blocking call and it was configured with web client, it would automatically call block for you. But you'd have to use web client to do all the requests because it's the only one that could do non-blocking. I think we're pretty close to the end. I wanted to just show some documentation support that we have called REST docs. So this is opposed to like something like OpenAPI where you generate everything. This is handwritten documentation that imports snippets that you would define in your tests. So the idea is that the code you show in your documentation was actually compiled and run and verified, and then it gets included here in these little bits. Okay, Spring REST docs, and that takes me to the end of this tour.
Special formatting for your documentation, like doclet in old days.
What format is it in? I think it's ASCII doc by default. But otherwise, it's just you write your documentation. It's free form.
Certain things to be like a queue for the developer or something. You don't want that to be a part of the API documentation. It's a program documentation, not for the API.
Yeah, I'm not sure. Thanks. More questions? Yes. GraphQL question, okay?
So two questions. So one is, what was the motivation behind GraphQL, and any kind of recommended kind of use cases that kind of fits in perfectly for GraphQL?
So you're asking specific use cases for GraphQL?
Yeah, use cases, and what was the motivation for GraphQL?
So part of the motivation was to be able to define the queries up front. So that's one. The other is to only get back the parts of the data that you specifically requested, right? So you ask for, you don't get the whole customer back if all you need is the name, right? So it's for some of it is efficiency on the wire. Some of it is efficiency in your team to be able to collaborate. So there's something called GraphQL Federation, for example, where you could have different teams working on bits of that API, and they get brought together in one thing.
Okay. And so the Spring Cloud Gateway kind of also does that kind of aggregation, right?
Yes, but it's a more traditional HTTP API gateway as opposed to GraphQL specific. But yes.
I have a question. So right now, all the API or pretty much use pretty much use Toolbox to talk. Is there any utilities or that you guys can framework itself, right? We can do more first and do that. So I don't need to maintain,
So this gentleman here that is just leaving, Rob, with the backpack, is on the Spring security team, and he can tell you, him and his colleagues can talk about OAuth a lot. You'll be at the booth at some point, won't you? Yeah. So we're taking turns at the booth over here, so you might be able to find someone there. I lean on them for all my OAuth dealings.